Hello, everyone. We are going to take just a few moments to let people file in. But in the meantime, feel free to add your questions into the chat. And there'll be also plenty of time after the presentation to ask any questions that you have as well. But when we're ready to go and a few more people have joined, then there'll be chances to ask kind of throughout the presentation, although most of the time will be towards the end. And I'll do an introduction once everyone gets here. If you have any troubles with audio or video or anything else, also feel free to put those in the chat, and I'll be happy to address any technical issues too. For those folks just joining now, we're going to wait a few more minutes to let everybody filter in, but you're welcome to ask any questions either in the chat or the questions tab. And I'm happy to answer those now before people start joining. And I'll also be giving about 15 minutes towards the end of the presentation for anybody to continue asking questions after all the content's been gone through. So just as a quick example of how the questions will work today, for anybody who's filtering in, you're welcome to ask any questions in the questions tab. And then if you'd like to, you can upvote those questions if you agree with someone else's and you want to learn more about those. And that'll help me prioritize any new questions that come in. This was a question that was submitted earlier, so I put it in the chat myself, in the questions tab myself, specifically about which cloud providers we'll be focused on today. In the course of the presentation, I will mention a few different cloud providers, but the example code that I'll be using and sharing with you after the workshop will be oriented towards AWS. Although it's fairly similar in terms of the certificate creation process we'll be talking about for multiple different kinds of clouds, that's where we'll be focused for the most part. Although we will be taking a look at different architectures on different clouds that are fairly similar to what you would do with AWS. Now I'm going to give it maybe another minute just for the last few people to filter in, and then we'll get started looking at how to connect our devices to the cloud today. Again, if you do have those questions or want to enter those into the chat, feel free. It's going to depend on if you put them there. If I hear them in the questions tab, I will probably hear a little noise that will tell me to go take a peek. In the chat, I might not be able to hear as well. So definitely feel free to save those questions towards the end too if you don't get them answered. Today, we're going to be looking at connecting IoT devices to the cloud, and I'll do one more check for anybody else who might still be straggling in before we get started. Perfect. Looks like we have a decent number of folks here, so I don't want to take too much longer to wait for anyone else. So I'll jump into a few introductions, and then we'll go through some of the material. To get started, we're looking at connecting IoT devices to the cloud today. So some context on who I am. My name is Fernando Medina Corey. I'm a lead cloud architect at Witekio. I've worked in several different cloud providers. I've worked most extensively, I'd say, with AWS and then more recently with Microsoft Azure, but I've built applications in Google Cloud Platform. I've spun up different services throughout cloud platforms like Alibaba, and really just have had my hands pretty deep into cloud technologies for the last several years. So today I'll be talking more about the IoT side of that and how IoT and the cloud connect. To give you a quick overview of what Witekio is and what we do here before we get into the main content of the presentation, Witekio itself has over 18 years in embedded and IoT software experience, and we have over 130 people throughout the world working both on embedded side, cloud side, and kind of throughout the stack of IoT. We also have a bunch of different customers that we work with through the entire stack, from the cloud down to towards the hardware layer, but not building hardware itself. So if there's projects that kind of span the scope of what you're seeing here, it's pretty likely that someone at Witekio will have either a piece of experience in that stack or have worked with it pretty extensively before. So a quick overview, now that hopefully people have started to filter in, of what we'll be doing today. We already kind of did a little introduction. I'll take you through a minor introduction of IoT and the cloud in general and why those are so important. And then I'll move on to picking a cloud platform and some of the considerations you might have for that process as you're doing that. From there, we'll go through and look at the device manufacturing process, which I think is one of the most obfuscated and confusing parts of the process when you're coming from a cloud perspective. It might be more familiar to some of you who've already had quite a bit of IoT embedded experience, but we'll go through that process just to connect the dots and make sure we're on the same page. From there, I'll take you through a few sample IoT architectures and use cases, both in examples with the main cloud we'll be focused on today, which is AWS, but also similar architectures in different clouds as well, as they do have a lot in common once you start to see the similarities there. Then towards the latter end of the presentation, I'll do a demo involving a device I have on my desk right here that is turned on and will be working for the purposes of a live demo and or a video demo for whatever reason that fails. From there, we'll go into some tips and tricks around what you need to know when you're developing your own cloud IoT applications, common gotchas, and really just things that can save you both a lot of work or potentially a decent chunk of money, depending on what you're doing in the cloud. And then towards the end, we'll look at a few ways you can start leveraging the cloud, specifically with IoT, and tie it back to some of the things that Witekio has been working on. So before we really dive into everything, I just want to say once again, feel free to put any questions you have in the question section. Feel free to put some chat inside the chat section. I'll be saving some time towards the end for any questions that anyone has to make sure I can answer those and get any additional resources out to anyone who needs them. Okay, so it's a few minutes past the hour, so let's dive into the content today. So as a quick introduction, what is the big deal around IoT and the cloud? Why is it such a big deal for IoT? Well, some of the context that we have to think about here is that there's 35 billion devices that are connected today. The last time I was able to check into the metrics, and customers are constantly demanding more connectivity from their devices, as well as some complications that come into the IoT space. When you're working with IoT devices that have maybe been around for a little while and you need to do some maintenance or replacement on those devices, there's also the possibility that the certificates used by devices to secure connections between devices and the cloud might be expiring depending on how long they've been active and how long the length of certifications that are or certificates that live on those devices will last. There's also a lot of different IoT solutions, dozens of them out there, both cloud providers, independent providers, open source materials that you can use to manage your IoT devices. And it's really difficult to pick a single one when you're looking out there. It can be kind of confusing to even make those choices. Now, there's a lot of possibilities that the cloud leverages and enables too. It can let you remotely manage the updates and patches of your devices. It can help you do things like predictive maintenance and alerting, depending on the industries you're in and how much data that you're generating. It can really provide some utility there. And it can help you automate and optimize some of the collection and storage of the data you're generating from those IoT devices. Outside of that, there's also the possibility for business intelligence reporting. If you just want to plug your devices in and the data that they're generating into some sort of dashboard or other things like that, that's another critical layer of what that might encompass. So that's just some broad context and broad overview. But let's assume that we're already at the point where we know we want to connect our IoT devices to the cloud because we have either applications we want to build in the cloud, or we know that we need to put our data there and we might be moving away from an on-premises environment. So how do we pick the cloud platform that we want to use and interact with our IoT devices? Well, there's a lot of different considerations here, and I definitely wouldn't say to jump into any particular cloud without going through the requirements that you have. But at a high level, there's two cloud platforms that we've been focusing on more at Witekio. Not to say we haven't used other cloud platforms, but primarily we've looked at AWS and Azure. And the reason for that in terms of cloud, not necessarily any specifics for the IoT side that we'll get into in a little bit later, is that they're the two top public clouds at this time. In the last several years, both in 2018, 2019, and 2020, AWS and Azure have consistently ranked within the top two clouds throughout all of the providers that are available. Now, there's lots of other options and lots of other options that have substantial IoT offerings. Google Cloud, other IoT platforms such as Avnet IoT Connect, and other cloud providers throughout the world that might have more sophisticated footprints in particular regions. But at a high level, we usually start to ask if those two clouds are going to be effective, both because we have a significant amount of experience in those clouds and because overall they're still the top two leaders in that space. So that might give you a little bit of context on why initially looking there, but other things like open source tools might also be able to integrate with both those public clouds or any of the other clouds out there. So why AWS and Azure specifically? Well, I think the most important thing to think about for IoT is that both of these clouds have pretty robust Internet of Things IoT device platforms within them. AWS has the AWS IoT service and Microsoft Azure has Azure IoT. And both of these platforms they don't just have the single service that IoT devices connect to, they have a whole suite of additional services around those two that allow you to do a lot of interesting things. AWS has AWS Lambda. Microsoft Azure has things like Azure Functions, which plug in very effectively to the sorts of work that you might want to do. And in addition to those, there's database offerings that connect very neatly with any of the data that you're ingesting, such as DynamoDB or Cosmos DB in AWS and Azure, respectively. And then analytics platforms like Microsoft BI and AWS QuickSight. Both of those are different options to visualize some of the data that you might be storing in the respective databases in either of these platforms. Now, there's a lot of other offerings within these clouds as well that you can use to store data, to process data, to take different insights and actions off of it. But at the high level, these really have lots of different options for everything from streaming analytics to data processing to really everything else that you might need to do. So with that context about why AWS and Azure, let's look at what the first step might be in whichever cloud we're using to start getting our devices connected into the cloud provider that we choose. Now, there's the first step, which is authenticating our devices to the cloud. And when I'm talking about authentication, I mean having the devices prove that they are who they say they are. The first step that you could choose if you're using Microsoft Azure is using something called symmetric keys, where you have a key that exists on the device. Usually you will want this to be unique for every single device that you have, and then that can be used to connect to Microsoft Azure. Now, this is only available currently in Microsoft Azure, not in AWS, but both AWS and Microsoft Azure have an option to have X.509 certificates on a device, where they'll connect from that device into the cloud and be able to authenticate with that certificate. Now, while there's options for standalone certificates, which are not tied to a chain of trust up into some higher level certificate, the more common option when you're getting into manufacturing and industrial scenarios with lots of devices is to have some sort of X.509 certificate chain or public key infrastructure. And what that looks like is essentially having a higher level certificate sign lower level certificates, having that higher level certificate trusted, and those lower level certificates going on devices to allow them to authenticate to the cloud that is currently trusting that higher level of certificate. Now, there's some other mechanisms you can use as well. There's things that other providers use that involve something like JSON Web Tokens, sometimes as well with a CA cert. There's processes you can use for device claiming. In particular, Azure Sphere is a manufactured device that's been partnered with Microsoft Azure and some manufacturers that essentially allows you to, rather than manage all the PKI on the device, simply just claim it to an Azure tenant, and that eliminates some of the processes of renewing certificates, dealing with security updates and patches, and has more of a managed hardware aspect to it than really many of the other offerings out there. And there's other things you can do outside of the typical X.509 certificate model, where in addition to having something like that, you can store cryptographic information on a trusted platform module on a device that might be a little chip that's soldered into your physical device that allows you to do those cryptographic operations to really help with that whole process and make sure that it's as secure as possible. So now that we've seen some authentication mechanisms there's also authorization mechanisms, not just that the device is who it says it is, but also that it can take the different actions that we want it to take. So in the case of Azure, that might be something like shared access policies, or potentially taking downstream actions from the Azure IoT hub through some event system and then getting processed to do something else. But in the case of AWS, that might be something like IoT core policies, which say, can this device send information to this particular MQTT topic? Or can this device take some action that triggers an event interacting with another AWS service? So those are things you have to think about when you're connecting your devices, because you want to make sure that they're only allowed to do what you want them to do. And there's some other AWS complications and services in there using identity and access management, policies and roles, as well as something called the simple token service, and using tokens that are generated from that. But behind the scenes, there are these different mechanisms essentially to make sure that those devices will do only what you want to allow them to do. So now we have a high-level understanding of authentication, of authorization, and of really how we would start to get an understanding of which cloud we might want to work with and what those clouds authentication and authorization mechanisms are. So the next step, which I think is one of the most interesting and sometimes one of the most confusing, especially for people coming from the cloud direction, is the device manufacturing step. So with the device manufacturing step, I'm going to be focusing more on the X.509 authentication flow. There are lots of different ways you could set up a device manufacturing setup. You could use something like Azure Sphere, which I mentioned briefly, where devices would be claimed to an Azure Sphere tenant, and you wouldn't have to deal with certificates. You'd also use symmetric keys that you would have to make sure to use uniquely on all devices, although that's not a recommended step for production. So I'll be focusing on X.509 certificates because it's one of the most common ways to integrate in that manufacturing process. The first step here is that you'll have a root certificate. Now, it is possible that you might purchase a certificate from a provider who allows you to get your certificate signed up through a public chain of trust. That's usually the route you would go when you're getting a certificate for something like a website, where you want all of the browsers of everyone who's visiting the website to automatically trust that, because that certificate is signed up through a chain of trust to that public provider that offers that CA cert. Now, with the X.509 certificates for your own devices, you might choose to go that route and purchase a certificate. You also might choose to self-sign and use your own. There are different options and reasons that you might do either one of those, primarily just depending on which devices you would like to trust up through that chain of trust, or if there's other reasons that you might need people to trust that certificate without having to go and do additional configuration. So whatever it is, you'll start with a root certificate, which will be registered in the cloud provider. And that will then create signing certificates or device certificates. And we'll get to the differences between some of those in a moment. Now, the signing certificates are intermediate certificates that you can create as kind of a stage in between your top level certificate and your device or leaf certificate. And those exist to sign trusted device certificates, but they're not required, as a root certificate can also create leaf or device certificates. Now there's all the device or leaf certificates, and these will authenticate an IoT device with the cloud. They'll be stored securely on a device, potentially on partitions that are more secured on the device through some of the means that you're creating when you're writing your operating system and dealing with some of the configuration at that lower level. But essentially, these are what's going to allow these devices to connect up into the cloud and make sure that they are who they say they are. So how do we go through this process with AWS? Let's imagine we're going to start using the self-sign model that I mentioned, where we're going to create our own certificate. Then we'll create a verification certificate, which essentially is a way for us to say, okay, we've created our own private key, we've created our own certificate. AWS, here's the certificate I'd like you to trust. But then AWS says to us, well, you have to prove that you are who you say you are and that you own this and control the certificate. So make us a verification one to show us that you can actually do that. Then we're able to register and activate this and use it to provision devices down the line. So let's look at some of the code for how we might do this to get into this. I'll skim through this quickly, but all of this will be available later on to anyone who'd like to take a look at this particular demo. And it is actually the code that I've used for the demo that I'll be demoing later today. So the first thing would be to pick a tool to generate your certificates. In this case, I'm using OpenSSL. And I'll be creating our new root key, which I'll be using then to generate the verification certificate and all the leaf device certificates later on. So we'll start by doing that, creating the key, and then we'll go to the next step, which is creating the verification certificate. The way this works is the cloud will give you a code. It'll essentially be the proof of how you're demonstrating that you can create certificates with any CN or code that the cloud wants you to. So in this case, I'm running a command against the AWS CLI and saying, hey, give me the registration code that you want me to prove that I can create. And then you'll create a new key and then a new signing request with the verification code to say, okay, well, hey, we're going to prove that we can create a certificate with this. And then you'll send you'll use the root certificate to then generate that output verification certificate and send it up into the AWS cloud to say, hey, hello, I have created this. Here's proof of everything. Here's all the extra stuff that you might need in order to configure this and make sure it's correct. And at that point, AWS is usually happy and will let you then say, okay, you've verified that you own this root certificate. Now let's go ahead and let you activate it. Now, that's a lot of code, so let's visualize this really quickly, and you'll have access to the code later if you'd like to. So basically what's happening here is your root certificate exists. You have it. You have your private key and your certificate. AWS says, okay, you say that you are the owner of the private key as well, but you have to prove it. So here's a code. Then you create a new key certificate signing request, and you sign it with your root key. And then you send it over to AWS and you say, okay, well, here's the proof that I own this root key and root certificate. And AWS says, okay, I understand. Thanks for sending that over. You activate it. And then AWS now trusts that you are indeed the owner of that root cert and the private key. So that's how that entire code process works in a visualization form. So now that we've done that, the next step is to create device or leaf certificates for our in devices. Now, of course, there was the option to create an intermediate or a signing cert, and that would be frequently done in manufacturing scenarios where, for example, you might want to send a intermediate certificate out to a manufacturing environment, but you don't want to give them access to your root certificate because that's a much higher risk than sending them an intermediate. So you send them the intermediate. Maybe that's used to sign 100 leaf certificates or in-certificate devices. And then you can send them another one if you don't want to continue to let them use that one. Or it gives you an option to have schemes where you'll invalidate a particular intermediate signing certificates so that if something goes wrong, there's an error in the manufacturing process, a bad actor, you have some fallback for how you'll do that. So when we are creating the device or leaf certificates, first we authenticate an IoT device with the cloud using that, and we have to make sure that device is going to be stored securely on the device. So in order to create this, we'd start by creating a new key for the device, and then we would create a new certificate signing request, which would allow us to use our root certificate to say, hey, let's go ahead and sign this new one that we've created so that AWS will know it's trusted and it will be able to connect into the cloud. Another thing we'll have to do as part of this process is to create a certificate chain, which essentially says here is the trust all the way up through to the root that says this is signed by this, which is signed by this, to make sure that we have that chain of trust kind of going back. The last thing we'll need to do in this sort of setup is really just setting up the ID of whatever device we're sending in. And then in the case that I'm doing it here, we're also getting an Amazon public root CA, which will go alongside in our device in order for us to try and register that device by using the new certificate chain we created, our key that we're using on the device, and then some of the AWS public CA to establish some mutual communication between both the device and the cloud. The last pieces of the code you see here are really just logic that's included from creating some resources in AWS, which allow you to connect and communicate in with the IoT core service and send an initial message to try and register this device for the first time. So what we really did here is we had the root certificate, we created that intermediate signing request. And like I was saying, this can be used in a manufacturing environment to sign individual devices with a unique key. But in the background, what this looks like is each of these devices is going to have a chain of trust up through that red root certificate that shows, hey, we are authenticated and we are able to connect into the cloud. So now that we have a little bit of that information kind of visualized and out of the way, let's look at some of the provisioning options. So we've set our device up with a proof that it should be trusted to connect to the cloud. But how do we get some of the basic information about that device? If you think about if it's a light bulb, if it is a connection to a TV screen or something like that, we need to know what configuration options, what values, what defaults we want to include with that device when it's doing its initial provisioning and connection. And we might also need to know what permissions it has to act on different MQTT topics or with different services. So there's a few different options we have for that. We can do manual registration, where we manually take the configuration of a device and we say, hey, here's the certificate it's using. Go ahead and connect it in and give it these different options. That's not the most efficient way when we have lots of devices that we want to do that with, though. There's also an option in AWS to use something called just-in-time provisioning, where we use a template to say, here is a template of every time a device connects that is chained up from this root CA that we've already authenticated. Give it these permissions and these bits of information based on the ID of that device. Now, there's also the option to use something called just-in-time registration, which rather than using a template, allows you to do some custom coding to determine how a device is going to be allowed to get configured. So it can call out to another service. In this case, it uses something called AWS Lambda within AWS to run whatever custom code you'd like during that provisioning process, which will take that certificate information in from the device and say, okay, let's go ahead and configure it however we'd like, maybe splitting it between one region or another region, depending on more of the metadata on the device. Now, there's another option where you could use something called trusted user provisioning. This is another way for example, customers, or technicians in the field to do some provisioning more manually as another option. And there's one other option that can come up in some situations where you have a shared claim certificate, which essentially allows you to use one certificate on any number of devices, but then claim a unique individual certificate after that. The one drawback of this model is that, as you can kind of guess, this means you have to be very careful with your claim certificate and potentially renew it or change it periodically to make sure that even if it gets compromised, it's not going to be used to create a bunch of new devices and pollute whatever system that you're working with and cause issues. So that's on AWS. Let's really quickly look at how that just-in-time provisioning process works. If we have a device with a unique leaf certificate that's been signed up through that red certificate that's trusted in AWS, the first step is it tries to connect to AWS IoT Core. And then AWS IoT Core sees that it is using the template for this just-in-time provisioning process, and then replies and says, okay, here we're going to set up an IoT thing, shadow, and a policy for the device that can be used. And then it returns that information so the device knows that it can do that. And that's essentially a way to store the device's state in the cloud and associate different policies with it for what it can do. Now, a very similar process happens with the just-in-time registration, where the device connects to AWS IoT Core, and then it's processed on a MQTT topic by a Lambda function, which has all that custom code, where we do the essentially exact same thing, but we have the option to call out to any other services before that connection from the device is made to that shadow and the policy and the IoT thing itself. Now, there's other options inside of Microsoft Azure for device provisioning. I'm just going to grab a quick sip of water. For device provisioning on Azure, there's actually a few different options as well, where we can do the manual registration, where we could use the portal, the SDKs, the APIs, etc., similar to what we could do manually with AWS. But there's also something called the Azure Device Provisioning Service, or DPS. And this allows us to create different enrollment lists and groups, which allow us to use things like similar to how we use the template in the AWS world, have our devices that are shared with a higher level certificate come in and get different information provisioned to them based on their enrollment in those enrollment groups. So some of the benefits of this model include that devices can be configured as soon as they're registered, as soon as they connect. You can load balance between different IoT hubs. If you have in Azure one hub in one region, one hub in another region, and you want to balance those out, or potentially do things like latency-based provisioning. So if you have a device that connects in Europe somewhere, you probably want it to connect to the European IoT hub rather than a hub in the Americas, given that that will probably be a bit faster. And you can also deal with multi-tenancy there as well. If you have multiple clients, perhaps, that you're working with, and you want to be able to separate those out into different tenants. It also has built-in key rotation support. So as you're dealing with keys potentially for symmetric keys, although that's a less common scenario for production, it does have the ability to help with that, as well as to help with the rotation of other identity mechanisms like certificates. You can actually have multiple set up to help you rotate those out as the certificate ages and you need to replace it with a new one. So let's really quickly look at that process looks like in Azure. So with Azure DPS, you'll have the DPS service provisioned and set up as a cloud resource. And then you'll have enrollments that you'll set up. And these enrollments might be something like an enrollment group where X.509 devices will allow you to use those groups, or X.509 certificates that are on devices will be allowed to then use that enrollment group. Or you could have individual enrollments where maybe it was a device with a TPM, so that soldered chip to a device that you want to allow it to connect into DPS. Or maybe you have symmetric key devices or individual X.509 certificates that are trusted by Azure that you want to allow to connect in. Well, both of those different options will go through pretty similar steps. The Azure IoT Hub must exist so that you can connect the device into that. But then let's say you have the device reaching out. It'll go first to the Azure DPS device provisioning service. If it's an individual enrollment, it'll then be shuttled off to that enrollment's configuration, and it'll be pointed then to an Azure IoT Hub, which will create a shadow or a twin, essentially allowing that configuration for the light bulb's on or off state, or the color of the light as a quick example in this case, to be inside of that information. That'll be returned through DPS to the device, which will tell it, hey, here's your IoT Hub connection. You'll have to go and talk to that, at which point it will sync up the information between the light bulb state in IoT Hub and whatever the light bulb state on the actual device is, to make sure that you can communicate back and forth like that. Now, a very similar thing happens with the enrollment groups. The only difference is, rather than maybe an individual X.509 certificate or an individual symmetric key, you're going to have that chain of trust up through the trusted certificate in DPS, where you'll go and connect and then be sent over to Azure IoT Hub to create that information, sent back through DPS to the device, and says, okay, well, here's the IoT Hub you'll be creating or you'll be interacting with, at which point it syncs that information back and forth. And the exact same thing happens in a very similar method when you have two different IoT hubs, where you might just communicate between one or the other, depending on the things we talked about, like multi-tenancy or latency-based provisioning, or other options if you'd like to do more custom workflows with some of that provisioning. Okay, so we've gotten through a lot. We've looked at a variety of different ways you can authenticate devices, authorize devices, how those work in AWS and Azure, some of the code for actually generating keys, certificates, content sign-in requests is the intermediary to help with that process. So let's look at some architectures before we jump into a demo that give you a broader perspective of what's possible inside of the cloud. The first thing we'll look at here is AWS, which is what we'll kind of be focusing on for this demo as a possible architecture here. So let's say you have a bunch of IoT devices. What will be happening inside of AWS in terms of cloud resources? These will always be connecting into a service called AWS IoT Core. While it is possible that you might have a custom service in AWS, most likely if you're leveraging the cloud, you're probably going to use the AWS IoT Core service. And this can be used to connect into different services to help visualize some of the information coming in, or to just process that information and share it between what's called the device shadow and the devices, which is that device state management that we talked about. But from there, you can also send information that gets sent in by devices out to other AWS services through something called an IoT rule. Now, that will allow you to say if a device is sending in data that you'd like to stream into backend data stores, you could send it to something like Amazon Kinesis to do that streaming into a long-term storage like an Amazon S3 bucket, or into more of an analytical processing storage like Amazon Redshift. You could also send it to a database solution like DynamoDB, which would allow you to have more real-time interactivity with that data if you'd like to put it behind an API and expose it to your customers. Or if you'd like to just really search more of this information, you could send it over to something like the Elasticsearch service. And many, many different options. These are just a very small subset of the different services you might send it to. Now, there's a very comparable set of architectures in other clouds. And in Azure, for example, you'd have your devices connected through the cloud gateway, the IoT hub, where all devices would get connected into first. And then from there, you could transform or work on data with something like Azure Functions. You could send it directly into stream processing with Stream Analytics, and send it to a bunch of different database solutions for warm and cold path data storage, send it to UI and reporting tools, really through the rest of the system. And both AWS and Azure will have many different options here for the different actions you can take and how you'll visualize everything. Now, as a quick bonus, there's one thing I did want to mention here, which is that all these other clouds will frequently have similar solutions. So for example, for Google Cloud, there will be a very similar IoT core, which will allow you to have that communication between your devices and the cloud, and then connect into different cloud services. And there's also similar things for other providers. The main thing when you're evaluating them is just to make sure that they have all the requirements that you'll need for whatever solution that you're building, and also making sure that if there's any services that are better in one cloud or another, that you think about how that might impact your final solution, the time of development that it's going to take you, and everything else along those lines. So now we're getting to the part of the presentation today where I get to show you a little bit of a demo. So in terms of all the certificates that I talked about earlier, I've actually already done that process, so we don't have to do this step by step. But what I've also done is I've created an architecture similar to the AWS one you saw earlier, where I have this Raspberry Pi that's sitting on my desk right now. Unfortunately, I've already eaten all the chocolate, so I'll have to defend something else like my water glass today. But we will be using a PIR sensor, which can detect some motion when I wave my hand in front of it, to make sure that if there's any motion in front of my chocolate or my candy and my dog tries to come in here and steal my lunch or something, that we'll know about it. Because that device and sensor are connected up into the AWS cloud, and will be processing the information that comes in through AWS IoT, and then go in and send me a text notification whenever any motion is detected, and also update information in a backend database so that we can see that information from a website as well. So I have all of that set up right now, so let's give this a shot. The quick architecture overview is that we have my standard PIR sensor. We have a Raspberry Pi device with all of the certificates and the program that I have running locally on it to detect any motion, and the easily stolen chocolate or other lunch item that I might have here. Now, the architecture for this particular scenario is using something called Vercel to deploy a web portal, along with Amazon Cognito to do some authentication into that portal to make sure that we have to sign in to see what's going on with my device. And then that's going to be interacting with a series of APIs powered by Lambda functions and API gateways, API gateway to get access to backend data, both from the IoT core and also potentially from a database like DynamoDB. Now, in this case, the notification that it'll be sending to me will be sent out through the simple notification service in AWS, which essentially allows you to send out text, SMS notifications to any cell phone or other device that you might like. And then all of the kind of communication between the devices and the IoT core will be handled through the certificates and everything else that I've mentioned previously. So here's a quick overview of some of the code, but rather than dive into any of these particular files, I'm going to try and exit out of my presentation really quickly. And I believe this should still be visible, but I'm going to double check. Yep, it looks like it should be. So I've already logged into my Raspberry Pi device. If I list out the contents of the screen here, you'll see that I'm currently on my Raspberry Pi that is on my desk right over there. And what I'm going to do is set this up so that the PIR sensor will not be triggered unless I wave my hand in front of it. So I'm going to point it away from myself. And you'll see that I have the device cert chain, that I have device cert and CA cert.crt. That's the chain of my devices cert and the root cert at the moment, because I'm not using any intermediate certificates. And that is essentially part of what I need to send in with any request to the cloud. I also have my run.py file, which will allow me to run this Python file, and then that'll trigger some of the code to interact with the PIR sensor. So that's what I'm actually going to run right now. I'm going to run right here Python 3. Looks like might be getting a little bit of lag here, so I might have to reconnect to this briefly. I'm going to go ahead and close this one out, and we'll try a new one. We'll do pi, SSH, pi. If I can remember my login, hopefully this one will let me get access, and my Pi isn't too mad at me. This is also why I have the backup video in case something like this happens. So it looks like it might be a little mad at me right now. So let's try this one more time. There we go, it's 10. I don't know why I did 192. All right, so now we're logged in again. Sorry about the delay there. It looks like I just had a terminal get mad at me for a moment. So let's go ahead and do Python 3 run.py. And now this will start the program running on the PIR sensor where I can wave my hand in front of it, and it'll detect my motion, and immediately it'll send me a text message. So if I go and open up my phone right here, and I'll show it briefly to the screen, you can see that little notification right there in the top left corner. Essentially, it's showing me, if you can see my screen, it'll be a little difficult, but I'll also show you it in the presentation, that there has been motion detected. And if I move my hand again, it should send me another message just now that says, hey, we've detected motion again. You might want to be aware of that. So I'm going to close this program because I don't need to send any more notifications. But let's go back to here. And here's the website that I've set up to interact with AWS. So let's log into this. I've already signed in before, but it looks like I just got signed out. So I'm going to need to really briefly grab some credentials here, and we'll sign into our backend. And now I should be able to see when the last time it was triggered is. So this looks like it was triggered because currently I believe it's on it is on Pacific Daylight Time. So it's triggered at 10:38 and 38 seconds, which should have been just about half a minute ago. So it's still working. It's still telling me exactly every time my hand is waved in front of this, and will warn me if my puppy tries to get up here and steal anything from my lunch. Now that we've seen how this works, I really just wanted to hop back into the presentation and briefly touch on some of the other points. So there's a lot that has to happen here to make this functional, and because of that, I can't go into every detail. But what I have done is I provided all the code that runs both the website, that runs on the device, that is required to do the manufacturing of the certificates and to log into the Raspberry Pi and place them on the device, and all the code that runs inside of the cloud and is deployed in the cloud to make the API for the front end work as well. All of that will be in this URL that you see here, github.com/fernando-mc/IoT-home-security-service. So if you have any questions, feel free to follow up after the presentation too, and I'm happy to give you access to any of this information so that you can take advantage of it. So now we've already done the demo. I won't need to show you the video, fortunately. Let's talk about a few tips and tricks, because I want to get through these and give you some time to ask questions as well. So a few tips and tricks when you're working with AWS and Azure. Both of them have different options for setting up your Azure IoT or AWS IoT configurations. With Azure, you need to pick the tier that you need. There's basic and standard, some options between those. You need to ask questions like, do you need bidirectional communication between a device and the cloud, or does it just have to go one way? And also tune the number of units that you might need and the capacity that you might need, or set up something like auto scaling, because that can help you reduce usage and save some money. With IoT Core, there's pay-per-request feature pricing, and you can reduce usage to only what you need. And same thing with the features, with reducing connectivity and messaging or optimizing things here. But overall, there's a lot of additional tips that you could get in with any cloud operations that you have. Things like right sizing, where you pick the right size for anything that you're using with instances or capacity units. And I am going to skim over some of these so I can get to any of your questions. Purchasing options, where you can use spot instances, reserved instances, or reserved capacity. And what these mean essentially is there are different ways for you to buy compute power in the cloud, and they might be appropriate depending on your situation to save you some money. Additional things you can use to improve the utilization you have in the cloud, things like managed services like AWS Lambda, which I used in the demo, auto scaling and load balancing, which are common concepts around different clouds, and then also buffering, where you'll send data into potentially a queue or stream data processing to get processed when your compute capacity is able to do that. Some specific optimizations you can make for IoT. In Azure, IoT hub tiers have pretty substantial differences between their costs. So basic tiers and standard tiers, there's a 60 to 80% cost reduction between the two. And if you only need one or the other's functionality, it's good to make sure you have the right one in mind. With AWS IoT Core, it's pay-per-request and utilization of features. So really, you just have to think about how to optimize what you're using and how to get around that. Other things that come up very frequently with data storage around storage classes in AWS and Azure, where AWS has standard storage, which is 0.023 cents per gigabyte in one of the main regions. But it also has other storage options which go down as low as what you're seeing here for deep archive storage that you don't need to get access to very frequently. And you can create automation to move things between those storage classes. There's also the exact same thing in Azure. They just will give it different names like premium, hot, cool, and archive, and you can create lifecycle policies to migrate them between there. Okay, so sorry for that. I just want to give you a few tips as you're thinking about using the cloud. But in order to really start leveraging the cloud for IoT, this is the point where I'd give you some information about what Witekio has done and can do for anyone out there who's interested in learning more about working with us. We can do everything from device management and provisioning, a lot of the things we talked about in the presentation today, through over-the-air updates, monitoring of devices, dealing with telemetry and communication between devices in the cloud, visualizing all the data that comes in, and handling the life cycle and management of all those processes, as well as creating web applications that might show a lot of that data and help you visualize it. And for many different cases where there's lots and lots of data that you can develop insights from using machine learning, developing and deploying machine learning models for that data. So if you have questions, feel free to contact me or reach out to Sid in our sales department to talk more about how you get started. One way we'll usually do that is to talk with any interested folks about a cloud workshop where you evaluate some of the needs and possibilities that you have and really help you spec out the applications that you want to work with, as well as prototyping different things that you're building out. A few guides I've listed here for any interested folks who want to learn more about how this Raspberry Pi was set up, connected to the cloud for the first time, or how other devices could be connected to something like Microsoft Azure. I have two more detailed guides here that you can look at. And as for anything that's been in this presentation, feel free to reach out to us, and we'll be happy to give you any of this contact information or other information. So now I think it's really just time to say thank you and open this up to questions for anyone who has questions. So I'm going to go back over to our workshop screen here. Let me stop sharing my screen, and then we will we'll open the chat up and any questions that are in the question section for you to ask. So really just open to you now. I don't see any yet inside of the chat or in the question section, but if you have any, I'm going to be here for another 15 minutes or so to answer anything that comes up. But until then, thank you for joining, and I appreciate your time joining me today. And also feel free to reach out to me after the presentation directly. So thank you. Let me pop open the chat window just to make sure. Also, feel free to say hello. We have 15 minutes. It's up to you how we use it. So one question I've gotten messaged separately before, which I'm happy to dive into, is more on the lines of how the front end pieces were put together. There's a few different options for doing that within AWS, um, either directly in AWS or through other providers that integrate pretty nicely with AWS. For the most part, if you're deploying a front end on AWS, there's one option if you have more of a static site that you can deploy with your front end, which is to put it in something called an S3 bucket and configure some static site hosting, potentially connect it to custom DNS. But there's a lot of other providers that actually do that process fairly well for you too and help you manage that. So in this case, I use something called Vercel. But there's also another provider called Netlify, which is very good for dealing basically the same thing when you have a web application that you'd like to put the front end of inside of something very quickly, get the DNS set up, get the caching set up, and try not to deal with most of that backend infrastructure. I actually prefer those vendors because they simplify that process quite a bit. And you can still configure your backend APIs within your application to work pretty seamlessly with that front-end application, regardless of where it's hosted. So that's one option that I'll usually take and is actually present in the code that I was working with today. Well, I don't see too many other questions, so I'm going to go ahead, I think, and end a little bit early and give everybody their time back. But once again, thank you all for joining today. I appreciate you hopping on the presentation, and feel free to reach out to me afterwards. I'm happy to answer questions after the event as well. If in case you did not see my email earlier, I will put it here, and then you'll be able to email me later on. All right. Put it in the chat right there. You can feel free to copy that. If you can't see it, it is fmedinacorey@witekio.com. And I'm happy to send the presentation out or send you any of the code samples or anything else that you're curious about. Thanks, everyone, and have a great rest of your day. Hopefully, we'll see you in another presentation here at Witekio soon.